Okay, welcome back, everybody, to another episode of the Flocode Engineering Insights podcast. Today, I'm very pleased to have a guest, Mr. Dr. Seán Carroll. And Seán is the founder of engineeringskills.com, and he has a huge course library with mountains of information on engineering analysis, structural design, and lots of other topics that we'll get into shortly. So, Seán is a former senior lecturer in structural engineering at the University of Exeter, and he has lots of stuff to share on engineering education and concepts. So we're going to get into those. So Seán, thanks a million and welcome aboard.
My pleasure.
So let's kick things off with my big question up front. Your life philosophy in a nutshell. Keep it brief and pointed.
All right, we're definitely starting off with a big one. Okay, so no pressure. What is my life philosophy? My life philosophy. That's
I know. That's
a
why
tough
I ask
one.
it up front.
Up front, yeah. I mean, okay, life philosophy. I suppose. I mean, as it relates to work, I suppose if we
Sure.
even niche down a little
I'll allow
bit and
that.
just focus
I'll allow that.
on work, you know. Thank you. I suppose. What my philosophy, I suppose, if you could even call it a philosophy, is really to just try and find work that you find fulfilling. I mean, I think that's really what's driven most of my decision making over the last, 15, 20 years, ever since I kind of left Bolton Street all those years ago, was really to just try and root out and find work that I find enjoyable to do, fulfilling to do. And that's kind of led me to try lots of different things and to move from one thing to the next. And, you know, I'd like to think I'm at a position now where I'm doing something I really, really do find very fulfilling, very enjoyable. And so I suppose if you could call it a philosophy, that's the philosophy. You know, try and not settle for something you don't enjoy doing. If you're in that position, you know, I mean, you're in a very fortunate position if you have the freedom to be able to do that, to jump from thing to thing and try different things. And so as much as the sort of freedom is there for you to do it, you know, find something you enjoy doing. That would be, if I could try and wrap up a philosophy, that's probably what it would be, you know.
You know, it didn't happen overnight too. There's a lot of trial and error in trying to figure out what it is that's fulfilling. And to find out what's fulfilling, you have to experiment with some bullshit that is not fulfilling.
Yeah. And I would say I have, I can now look back and say there are lots of things that I worked on or did as a graduate engineer, sort of moving up through the years,
Sure.
that I didn't find fulfilling at all. And so thankfully I was in a position to be able to move on from them, you know. And, you know, education really is that's kind of come to define what I do now. It's all really focused around education. And, you know, even within that, it has been a process of refining further and further what within engineering education I want to focus on. You know, so yeah, you know, you don't just sort of happen, or at least I didn't just happen on the one thing I like doing. It was as you rightly said, it was a process of evolving towards something that you know, that I like to do.
You know, it's interesting because that leads into my next follow-on question from that, which is what aspects of engineering do you enjoy the most? And what is it? I know you enjoy teaching and you enjoy sharing knowledge and you enjoy learning, but you know, is there something about the topic of engineering in general?
I think what I like most about what I like doing most is learning, right? I mean, I found when I left college, university, when I left with my degree, I loved learning. And once I left, the pace of learning rapidly dropped off. Obviously, you go into an office. In my case, it was Arup. I couldn't have asked for a better place to go and work as a graduate engineer. But even having said that, it was still the pace at which you learn things. Maybe it's that you learn different things, but I really enjoyed the sort of technical side of engineering and learning in university, and that kind of shifted quite significantly when I went to work as a graduate engineer. So I suppose to come back to the question, it's learning is the thing that I enjoy most, and then coupled closely with that is then teaching. There's nothing sort of more enjoyable in my book than kind of picking something I'm interested in. I'm generally interested in the sort of more technical side of engineering, sort of engineering, simulation, modeling, and that all kind of dovetails with coding as well. That's what I'm interested in. So I'll pick a topic. I'll learn. Sometimes I'll know about the topic from my sort of previous experience, and then sometimes I'll just learn it, then teach it back to people. So it's a very enjoyable thing to do. Engineering is obviously it's the application of maths and physics. I always really enjoyed maths and physics because they were the topics most that were so your inputs were kind of related, I found, at least, to your outputs, in a sense that if you put the work in, you kind of got a proportional amount back out in terms of your degree of competence, as opposed to the arts, which is what I found, which, I mean, maybe my brain is just not wired that way, but no matter how much effort I'd put in, it was always hit or miss in terms of what I'd get back out of it again. So that kind of has what's led me sort of to engineering, I suppose.
Yeah, you raised a few interesting points there. You know, the reality that sets in when you start work after university is, you know, first of all, university has a huge amount of material that you have to get through in a tight timeline. So you're covering the basics at pace, and you're frantically trying to get through exams, get through coursework, just tick all of the boxes, and you don't really have that much time to soak it all up because you're constantly moving on to the next thing. Then you go into the workforce, and most likely you're going to be starting at the bottom of the ladder on a very specific niche of whatever it was, in your case, ARP. But for me, it was the opposite, where the pace of learning when I started working was, I couldn't keep up with it. I was just could barely keep my lips above the waterline. And it was a shock to the system of, like, I spent all this time learning all this stuff and I've barely scratched the surface. And then you're out trying to get stuff done, and you're like, what? Like, does anybody know what they're doing? And, you know, as the years go by, you realize, no, not many people do know. we're all just trying to make it work, you know? And that's the reality of large engineering projects, you know?
I think, you know, it will be doing a disservice to the role of a graduate engineer to say that you stop learning or you don't learn at the same pace. I think really what it comes down to is you start shifting into learning different things, and to become a good project engineer, that's not something that you can do, or you can sort of develop that competence in university. You can't. You have to develop that on the job, and that's really much more around managing stakeholders, and the sort of technical side of engineering, you know, to some degree takes a back seat when you go into a consultancy environment, because there's just so much more that you have to learn. And you can only do it in that sort of workplace context. You can do all sorts of, you know, group projects in a university setting where we with my lecturer's hat on, you know, we try and make it feel like a real project, but, you know, it's not, and it's not really even approaching the intensity of a real engineering project. And so you learn a lot. So I can definitely recognizing what you're saying around, you know, you a lot of new stuff is hitting you hard and fast. For me personally, I just wasn't interested in that stuff. Really, not very, you know, by comparison to what I really like doing, which is, as I said, the more kind of technical.
What kind of stuff, what kind of projects were you on when you were at ARP, just for that short period?
Oh God, what was I on? I was on, let me see, what was it? There was so there were projects. I was Arup in Dublin. It was in their Wellington Road office just before they moved to their Ringsend office in
I did a summer,
so what was I working on?
of working there on the M50 upgrade with ARP. That's many years ago now. So yeah, I was in that office, I think.
In Wellington Road, that was a great office. It was an old, I don't know, was it a Victorian building or something, but a really old building. And, you know, you'd loads of people spread across the building, different floors. It had a really unique feel to it. And, you know, that was my introduction to industry-based, industry engineering. And as I said, I couldn't have asked for a better group of people to sort of bring me on and introduce me into that world. In terms of projects I worked on, what did I do? I worked on the Aircom offices there opposite Euston Station. There's a sort of a multi-story, I think it's it's a concrete frame building, because I was working on it. I came onto that project quite late, just as a graduate engineer. So, sort of design this, design that type thing. I worked on, what else did I work on? There was an architect's office was it Pierce Street? What is the name of them? I can't think of the name of them. There was the redevelopment of a large architect's office there on Pierce Street. That was a really interesting project. Again, it was a mixture of concrete frame building, but also steel frame for part of it as well. I designed, I like to say I designed, but one of the main projects as a very young engineer that I like to say that I had a large part in was the canopy outside of the Rotunda Maternity Hospital in Dublin as well. So that was one of my claims to fame as a very young graduate engineer. But then just a mishmash of less glamorous, if you could call the previous projects glamorous, less glamorous projects sort of spattered throughout Ireland, I suppose.
Okay, cool. One more question on philosophy before we change gears, and your approach to problem solving. Could you boil that down? How do you like to go about solving a tricky problem?
Yeah, this I do have a kind of a framework for that I use quite a lot, and it's quite simple, and it's probably not the first time you've heard it, but it's basically to keep breaking the problem down. So no matter how, so for example, if I'm about to I'll start with an idea for a course, for example, engineering skills, and that will start off as a very broad idea. Very often I won't know how to do, it'll be usually based around some kind of code that I have to write, and I won't know how to do it. I'll have plenty of books and I'll read the books, but it starts off as a big problem, and I can't tackle that. And so the approach is always to just break it down into smaller and smaller and smaller parts. And ultimately, you'll eventually get to a point where the problem is so simple that you can solve it. And then you just sort of build back up step by step. So that's sort of my tried and trusted method of solving
what
problems.
You've just described is really the essence of programming.
Yeah, absolutely. Yeah, I'd agree with that. Absolutely.
I agree. I totally agree. That's a great way of putting it. Okay, so engineering skills, what is it? Who's it for? And let's start there.
So engineeringskills.com is my website. It's an online learning platform, mainly catering to civil and structural engineers, both students and professional engineers. And it's basically an online learning platform where you can take courses, self-paced video courses on engineering, analysis, and design. As I said, we mainly cater for civil and structural engineers at the minute, but sort of broader ambitions would be to grow beyond that, and indeed grow beyond sort of what I personally am not capable, but what I have the time to work on. I think there's an opportunity there for not as sort of a broader learning platform, but one very much focused on engineers and technically minded engineers. So that's what engineering skills is, and that's who it caters for.
Based on my experience, I'm a member of engineering skills, and you summarized it pretty quick, but there is a lot more on that site than just the courses. You've got a whole variety of different tools and tutorials, and the amount of content on there is staggering. And for me, as you know, I've been working now for almost 14 years, and when I think back of my time in university, which is the only time you ever really have to dig into the theory in great detail, and when you have the space to really understand the theory, I wish I spent more time chewing on it. But as I said earlier, it's just such a fast pace. You can't really stew on stuff for too long, and you don't know the practical implications of the theory that you're learning. You just don't have the lens to look through. So now now that I do have that experience, I go back and, there's a number of different courses. You got frames, beams, you got a variety of different 3D modeling courses, you got cables, you have cable net structures, you're doing shells, plates. There's so much value in, if anybody, like, I know there's a lot of engineers out there that feel like their foundations are a little bit shaky. They're using these powerful finite element tools, but they're not entirely sure exactly what's going on, how these solvers work, what they're supposed to be doing. And when you go through some of those courses, you're working through the theory and you're building it out and you're explaining what you're doing as you go. And you're always going from point A to B to C, and you're not going like A to D and then like, what did he just do? How did we warp to D? And I found that very helpful when I was going through your courses. I really like the one on Blender. I'm a big fan of, you had a modeling course on Blender. That's really good. So for anybody out there that wants a structural analysis and design deep dive at your own pace, where you can follow along and learn a lot of these important principles that you may be rusty on or that you never quite grasped in the first place, there's nothing out there, I think, that's like engineering skills that does it the same way, as far as I can tell. There's university lectures and stuff from different guys on YouTube, but I found your production value and the content to be up at the top. That's just one guy. That's just my thoughts.
I appreciate that, James. Thank you. I suppose I'd probably make a couple of points there in response. Well, I really do appreciate you saying that. Thanks very much. You are indeed a member. So I suppose the first thing I'd sort of point out is, like, that is really, when you said we sort of go from A to B to C to D, and we don't jump. That's one of the really guiding things behind when I'm making a course or a tutorial or maybe a smaller scale project. The main thing, because it used to really wreck my head when I was trying to learn something in university myself, and something will get skipped, and all it takes is for you to miss one thing. And once you've lost that one sort of link in the chain, the whole thing falls apart for you. At least it did for me anyway. So I always really do try and provide the sort of logical linking from one thing to the next, because I really think that is it's just so important, really, to help you build up the knowledge in your own mind. The other thing then is, I suppose, what's interesting, another thing you said, which kind of resonated with me, was when I started making courses in engineering, I originally thought that they were going to be taken by students, predominantly by students. And you can sort of see, the courses as they're laid out on the website are more or less in chronological order. And you can see the earlier courses I was making were very much aligned with what I was teaching to firsts and mainly first years in university setting, bending moment diagrams, and that's all really critical stuff. And so because I was teaching that on a sort of a daily basis to engineering students, I thought that it would be engineering students that would take the courses. But what I found was, yes, we do have lots of students, but actually lots and lots of the people that take courses on engineering skills are engineers. Because after I've talked to them, I've spoken to them, like, people email me and ask me about this, that, and the other, and when I get chatting with them about what courses they've taken and why. And like, it really does ring true what you said there, where a lot of them are engineers that have come out, and let's say, like, one thing that's covered usually quite poorly on an undergraduate degree in engineering is structural dynamics. That's one thing. Like, I've taught that in person in a university setting to university students, and they've really
difficult. It's
found
a very difficult topic.
It is, yeah, it is. It's difficult in the sense that, well, yes, it is, because you're used to dealing with, until you hit dynamics, everything is sort of static, and you can wrap your head around statics relatively quickly. But when you get into the world of dynamics, you start getting into differential equations, and if that was a little bit shaky for you in your maths, then you're on shaky ground to begin with. So dynamics was always something that that students find difficult, and that sort of propagates through to working engineers who, I remember when I was working as an engineer, anytime anything with dynamics came up, like, I went and did my PhD was in structural dynamics, but before then, I had not really much knowledge in dynamics, but anytime dynamics came up in the workplace, the solution was, oh well, we'll just factor the static load by X or whatever X is, and fingers crossed it'll be okay. And it was okay, as far as I know. But the point is, you've got lots of engineers out there who a short-ish, sharp, focused course on structural dynamics is really, really helpful because it gives you that grounding in single degree of freedom systems. And if you covered single degree of freedom systems as an undergraduate, you're in good shape. Very, very, very few people cover multi degree of freedom systems. Which we can decompose those down into a collection of single degree of freedom systems. It's fine. So it all hangs together quite nicely. But it is really helpful to have somebody guide you through that whole process. So yeah, that's just I agree with
And
you. Yeah, that's what lots of
the
people tell me.
reality is that wherever you are working as an engineer, there might be somebody in the office that has a great background in dynamics, and you can go and you can tell them that you're stuck and you can ask a question. And, if you're lucky, they have 5-10 minutes to explain some sort of a concept, maybe sketch something out for you on a whiteboard. That's what I try to do with a lot of our junior staff here. But the difference is like, I can't spend 2-3 hours providing like a detailed overview of the fundamentals and why this problem is occurring, and that doesn't exist in the real world. And self-directed learning is the only solution to figuring out those kinds of problems. And there's a book on structural dynamics by Chopra. I'm sure you're familiar with that book, are you? Yeah,
I have
that
it
book
outside.
was
Yeah,
we
yeah.
covered single degree and multi-degree freedom systems in university, but like, I don't know what we were doing. I was just trying to, get through the exams, and there was always that like there's always that like
Yeah.
that layer on top of whatever you're learning is like, okay, it's just, you got to get through the exams and get across the finish line.
I know it
And
was.
little do you know how important this will be 6 years later when you have like, this specific dynamic problem where, there's fatigue cracking on a temporary support structure. So like, that, first of all, for anyone out there, that book's fantastic. And Sean has a lot of great stuff on dynamics, and it makes it a lot less disgusting than it first appears.
It's actually, I mean, dynamics I love it as a topic. It's a super interesting topic. Like, just focusing in on dynamics for a second, there is a landscape, right? I think of dynamics as like, there is this landscape, right? And the landscape is all of the different possible analysis methods that you can use to model a dynamic problem. And you don't have to dive in deep and understand every single one, but once you've understood the overall landscape, that you can navigate and identify the different solution methods and modeling techniques, the mystery kind of drops away from it, really, because you start to understand, okay, well, this method won't really be suitable here. I will have to use that method over there. Is the thing linear or non-linear? All these really interesting topics. But you can go a long way in dynamics by just having an understanding of the overall landscape, and then understanding single degree of freedom systems, modal decomposition, and that'll get you 99% of the way there. So anyway, that's my sales pitch on dynamics.
That's good. So what are you kind of touched on it, but what your future plans? So you're thinking of expanding to cover more disciplines. Like, what are your thoughts on that?
Well, this year we've started having guest contributors. So basically, other people writing tutorial articles for engineering skills. One of the most prolific is a former student of mine, Callum Wilson, a fantastic young engineer now. He's been really helpful in producing some really good design focused. That's his what he likes to focus on, really, is
Steel
design.
right? I think I've seen some of
Callum's
those.
been producing content. Yeah, he's just wrapped up his series on steel design Eurocode 3. So we've got that, so I'm basically, and there's other other projects, sort of engineering / data science, computational fluid dynamics, that are kind of pieces of work that are in production at the minute that are, I'm working with people on. They're writing it, I'm just editing it and reviewing it. So that's kind of the first level, if you like, of going beyond me, basically, because I'm the bottleneck, really. I have a stack. We were talking before, and I was telling you, like, I have a list of, I don't know, probably 20, 30 courses. They're all topics that I find really interesting, that I can't wait to just sit at my desk here and work on. But that work can only go at a certain pace. Learning the thing, or dissecting a topic is one thing. Then the production of a course on top of that, in terms of writing lectures, designing a sort of a learning pathway through it, writing the lectures, recording, producing, publishing, it takes a huge amount of time. So I can only move it so quickly. And I'm also, there's lots of stuff I want to cover before I even get near computational fluid dynamics, for example. That wouldn't be something that I would be, I'm pretty sure I could do it, but it wouldn't be the best use of my time, because I want to start looking at all these really, I'm looking at stacks of books on my desk here, all these really interesting areas of, computational form finding and grid shell structures and all this, really, and that's what I want to focus on. So I would like to get other people who are interested in producing online courses to produce courses and publish them on engineering skills. I'm not at a, the invitation is there. I'm not pushing very hard on that right now, because there's another stack of projects that I want to get to the end of. But by all means, anyone who's watching or listening to this, if you see yourself as a potential course creator, and obviously there's a revenue upside for you as a creator, I'm very interested to hear from people. So yes, that would be another iteration that engineering skills will go through in the not too distant future.
That's very cool. I think it's a great idea. So shifting gears a little bit to your background as a university lecturer, and what are your personal opinions on the current engineering education system, just based on your own experience? You don't have to put the noose around anybody's neck or anything. I just mean
I was going to say, how long have you got?
I just mean, broadly speaking, you spent a lot of time in the educational system. What do you think about it? Sure. And what were the big pitfalls? And what's your opinion, I guess, just in general, on engineering education?
That's a really, really big topic. So I spent 10 years as a lecturer in 3 different universities in the UK. I started off in Nottingham, that's where I did my PhD, and then I went to the University of Warwick, and then I went to Exeter, the University of Exeter. So for a time in the University of Exeter, I was the director of education for engineering there. So I sort of saw, as time went on, in my time as an academic, I tended to focus more on education, on the education side of the job. And I loved
Sean,
teaching.
What do you mean by
most,
that? Like, you focused more. What does that mean?
Okay, so the role of an academic, generally speaking, has 2 main pillars to it. There is research, and there is teaching. So you, as an academic, this is a broader issue, but there, certainly in a UK context, your job really is to be a researcher. Certainly if you're in a university, as opposed to what? Yeah, as a Russell Group. So I was in Russell Group University. So if you're in one of those universities, very much your role as a young academic is to be a researcher and to generate research funding, to bring that funding into the department. And your progression in your career is heavily, heavily linked to that. And that really does not dovetail well, and is not really compatible, for the most part, I would say, with providing with focusing on education, right? Because there's only so many hours in the day. You're either writing grant proposals or you're thinking about how you can deliver a really good educational experience. And it's only very exceptional people that can do both very, very well. They're out there, but that's a very hard thing to do. So I tended to focus more on education. So that was great. I loved teaching, and what I miss most about being a lecturer is the kind of relationship you build up with your students over the course of an academic year. So, I would have taught loads of different topics, loads of different courses, but every year you go in and you start off with a new group of, could be 30 students or it could be 200 students, and you're going through a process of teaching them a topic. And you get to know them and they get to know you, and you become more comfortable with each other over time. And, it ends up 99% of the time being a really great experience. Well, I thought it was great. I know I really enjoyed it. I enjoyed teaching in person, in real life, standing up and having the crack really a lot of the time with the students. And that was really conducive to a good educational experience. I always got really good evaluations from students. So that's what I miss most about it. What I do not miss about it is like anybody in any organization, the bureaucracy that goes with working in a large organization, and the competing demands on your time. You can't really get promoted as an academic unless you bring in research funding, rightly or wrongly. But that very often competed with teaching, which is what I enjoyed most. I don't think I really loved research, to be honest with you. I liked sitting down coding and coming up with courses and all the rest of it, but cutting edge research, maybe I'm being kind to myself, maybe I just wasn't that good at it, but I didn't love doing it. I was more of a teacher, so that's what led me to kind of what I'm doing now.
So that's the structure of the courses and the learning material. When you arrived, do you inherit a curriculum, or do you get to design the curriculum? How does that work?
It depends. So generally, I remember my very first year when I hadn't even graduated with my PhD yet, but I'd been appointed as a lecturer, assistant professor in the University of Nottingham, and great experience, and I have nothing but good things to say about it and the people that were there. But I was kind of dropped in as a person that needed to fill some holes. It was a brand new academic. Courses needed to be taught because, more senior academics would have, I think, gone on study leave or something. And that's generally the case. When you're a new academic, you're at the bottom of the totem pole. You get all the apparently or perceived rubbish jobs. Now, I didn't think they're rubbish because I like the teaching side of it, so it worked out grand. So you would you inherit a curriculum. If you're going to keep that module over, for the foreseeable future, you would then invest a little bit more of your time in it, and you'd start thinking, well, what do I want this module to look like? And you are still having to deliver within a framework. So your module is part of a larger curriculum that has been designed, and so you can't just totally throw it out and start again. You've got to cover certain things, but how you cover them is generally down to you as the academic. So that's one way it can work. Towards the end of my time as an academic in the University of Exeter, where I was sort of towards the end of that time, I was the director of education there. We undertook a really big redesign of the curriculum, the undergraduate engineering curriculum. And that was a sort of a start from scratch, blank sheet of paper. What does a young engineer in 2022, I guess it was at the time, but now, what does a young engineer need to know, and how best can we teach it to them, and what does the best learning experience look like? And that was a very enjoyable and fulfilling thing to do. Very, very hard to deliver, obviously, because when you start a new curriculum across the entire department, everyone is starting from scratch, and it's a huge demand on people's time, and that then sort of pushed up against research demands as well, right? Because if you've got 60 academics in a department, and 90 to 95% of them are used to running on autopilot, delivering the same thing every single year, and you pitch up with your plucky team of educationalists and say, right, guys, we're throwing everything out, we're starting from scratch. No. You're not very popular, right? It's not a very popular thing to do. but it was worth doing, I think. But yeah, so that's the other way it can go. You can, from time to time, get a completely blank slate. Or what's really nice is someone says, your director of education will say to you, like, we want to start teaching a course in X. You're interested in this area, go away and design it. And that's a great position to be in if you've got the time to do it. And that's kind of what I do now all the time with engineering skills. So yeah, that's generally how it works as an academic or engineering education more broadly. I don't know. It's a difficult one because students' attitudes towards education, even in the 10 years that I was doing it, I could see quite a big
way?
shift. I was in because I was in a UK setting where partway through my time there, the fee arrangement changed, and so students went from having relatively low university fees, with the Lib Dem, Nick Clegg at the time, the Lib Dem, and David Cameron Tory government, the coalition at the time, they brought in tuition fees when they said they wouldn't. Well, Nick Clegg said he wouldn't. Now I wasn't a student, so it didn't kind of directly affect me, but it affected all of the students that I would see on a daily basis, and that slowly but surely, I think, sort of had an impact on the students' attitude towards their education. Not all of them, but a lot of them adopted more of and I can't really blame them to a certain extent, but more of a market-based approach to their education, in a sense that, well, I'm paying for this education, but really I'm paying for this qualification. And that kind of wasn't really conducive to, or rather compatible with, a student who was just there to learn, if you know what I mean. Like, they were kind of like, not all, some were just sort of like, well, I expect to get this thing, this qualification, and sometimes regardless of how hard I work. And it also led to, or sort of slightly related to that, was what you articulated earlier, which was just the need to pass exams. And that always, unfortunately, overrode the students' desire to just spend the time learning for the love of learning, really. Those two things should go together, right? But what I found was students would tend to identify very, very quickly where they could game the system, in a sense, like where they could focus the time to get them whatever they needed to get, right? And they would so for example, like dynamics, right, would be a hard subject. If I've got options in my fourth year, one of them is sustainability and X, and the other one is structural dynamics. Well, they aren't going to pick structural dynamics, are they? You know what I mean? So there was a lot of that.
Yeah, it's that's very interesting. It's almost like how, with government, it's just you join this big giant ship it's so difficult to change course, and you're just sitting on the ship with some bright ideas, but they're like, hey, Seán, we love your ideas, but this ship is hard to move and it's difficult to shift.
Yeah, I mean, that is absolutely that is, I mean, like my time as a lecturer was really fundamental in sort of shaping what I do now and how I do it now. So I would never diminish it too much. I didn't want to do it forever, and I got to the point where I was like, no, I'm not doing this anymore. And little things like I just hated sitting down in May or June to mark 200 of the exact same script. That used to just rot my soul. But so I'm quite happy to leave that behind. But then the work I do now is quite solitary, in a sense. So I don't have that many colleagues. I don't. There's no Friday drinks because I'm, well, there is actually, because my wife is downstairs and we'll have a few gins after this. But, generally speaking, it's quite a quiet lifestyle now.
When I think about engineering education, I always think like, if we're looking to hire new engineers, I feel like the ability to problem solve and the ability to just kind of, as you had mentioned earlier, break a problem down into its constituent parts. I feel like that is, when we're hiring people, they're the kinds of people that I am always looking for. It's like, okay, the theory is one thing. You need to have a baseline level of fundamental engineering theory so that you're vaguely aware of generally the kinds of things that we're trying to do here. However, there's like a whole skill set related to just solving a problem or going away and experimenting and hitting a brick wall and trying out 4 or 5 different avenues before you come back and tell me that I've exhausted every possible avenue here. Like, I need some help. And I don't really know how to add that into an engineering curriculum, right? It's like, it's such a vague thing, but it's a hugely valuable skill in, and not just engineering, in pretty much any profession.
Yeah. Well, I mean, that's what you're generally all engineering degrees will have some component of a research project in the final year, or a group project, which is a kind of an ill-defined problem where, you know, not everything is known. You're given a loose brief, and so, you know, you have to pursue different avenues to identify the right, well, not the right, but, you know, an optimal outcome. And that's what those things try to do, exactly that. You know, final year research projects are great for that, because, you know, students find them exceptionally challenging, because they're used to, up to this point, being told this is the curriculum. If I just come in every week and listen to Seán and make sure I understand what he's telling me, I should pass the exam. But, you know, final year projects are difficult and challenging because they're not that. They're what you said, which is, well, here's a loose problem. I don't know how to solve it. I have to logically just approach this from first principles and see, okay, well, what am I trying to achieve? What's the next step towards achieving that? And, you know, that's how it goes. And then that's why, yeah, I mean, that's why students find them tough. They're more like engineering than they are like passing a module.
Okay, cool. I want to ask you, so when did you start using Python?
I was just writing an email actually today out to all of my subscribers about this. When did I start? I started using Python when I was in my PhD. So I originally started using MATLAB. And then towards was it the end of my PhD, or had I finished my PhD? I used MATLAB predominantly throughout my PhD because that's just what was used at the time. And then I shifted over to Python, probably 2012-ish, around then. Very glad I did. Very glad I moved away from MATLAB. So yeah, I haven't looked back since. Python has been, I do a lot of development work, so I just code generally in JavaScript and Python. So yeah, that's when I started.
What do you think the benefits of learning to code are for an engineer?
I mean, I suppose there's the kind of obvious ones, which is, you know, being able to code it really is a superpower, because it allows you to access the sort of the power, the speed of computers. Like, computers are great at doing things that we're not great at doing. You know, they're great at computation without making mistakes, you know, repetitive tasks, and they don't get bored. And so if you can code, you can essentially communicate with an army of robots that will do pretty much whatever you ask them to do, right? So I love that idea, and it's something that I think about quite a lot. Or, you know, it's what motivated me in the earlier days to code. The less obvious one, I suppose, is well, we already said it earlier. It's really helpful for your problem solving and, you know, helping you think through problems. So, you know, most of my time is, if I'm not reading a book, you know, to try and understand something, I'm writing code to try and understand it. And coding, being able to code, is a great tool for helping you understand topics, concepts, because it allows them to jump off the page. Like, that's why I use so much coding and engineering skills, so much Python, because it really helps me to articulate what it is I'm trying to teach. So yeah, I mean, that's the benefits. And then the other thing I'd say is, if you can code, you are no longer stuck. Not that being in engineering is a bad thing, but you have an entry point into so many other different disciplines and areas. You know, whether you wanted to get into data science or data analysis, analytics, finance, various different other areas where your analytical mind the analytical mind of an engineer is valuable. If you can then layer on top of that the ability to code, you've basically opened the door to many, many other different things that you can do. So I think coding now it's table stakes. I think every young engineer should be, quite happy, coding.
I totally agree. Essential. And just to go off what you had said initially about, being able to control computers and machines, etc. Just for a practical application of this, so recently I was up in central BC. Is extremely mountainous here. I'm in British Columbia, Canada, and we were doing a survey for a new water conveyance intake, and we have no idea what kind of the detail of the terrain. So what I'm in the process of doing now is we're going to map out a drone path, fly it up there, take a bunch of photos in a grid, then come back, upload all those photos into some photogrammetry software, and then Python will be the backbone of all of this. And then we just create a LiDAR type contour map of the river channel. So now we've got actual data to begin our design. And the value of that, like a drone is $1,000 for a decent drone. You go up there, fly it around for a half an hour, and come back and do all of that work in Python, maybe a day's worth of work there. Like the value of that is immense, and all possible through Python. And that's just like, that's a fringe example. Most of the stuff that I do is structural design, hydraulic design, energy modeling, financial modeling, and all of that stuff is all through Python. And I see you using it in a completely different way as like an educational tool and as a means to explain, all these different finite element concepts. And I think there's, I'm preaching to the choir, but I think there's huge value in it. In your experience, what do you think are the barriers and the hurdles that engineers face with code?
That's an interesting one, because when I was teaching in the different universities, I found getting undergrad engineers to buy into, I could never understand this, getting them to buy into the value in learning to code was just so difficult. And I never understood why, because coding based courses on engineering skills are very, very popular. But undergrad engineers just, by and large, were not interested. And I don't know why. Maybe we just weren't doing a good enough job in showing them the utility and what they could do. I think that was probably it, because I think if I'd sat down in front of a group of third or fourth years and said, that really expensive analysis software that you can't use unless you're on campus, well, let's just sit down and build something that will do a refined version of the same thing. I think they'd have probably bought into it then. So that was a missed opportunity, I think. The things that is everyone's barrier to coding, right, is a lack of, this sounds terrible, but it's a lack of perseverance or a lack of time to dedicate to it. Because when you start off, you're just going to get hit with error message after error message, and it's having the perseverance to work through those, and slowly you will see that they diminish and they get less and less, and you'll recognize them, you'll know what it means. ChatGPT and generative AI has made this an awful lot easier now. So I think it would be very interesting to return to those undergrads, or today's undergrads, and try and talk to them about the importance and the benefits of coding now that they have this additional tool, which is generative AI, that can really massively help. It has massively sped up the time I spend coding. Certainly building out engineering skills is a lot faster now that I have Copilot and ChatGPT in the background as well.
I find a huge barrier is so when you initially begin with Python, you think like if you can understand the syntax, that's essentially it. And that is the Python language, is understanding the syntax and how to use it. But there's so much bullshit around getting set up and the
Yeah.
understanding and managing the environments and the installation and
Mm-hmm.
your workspace.
Mm.
And there's just it feels like you're spinning 10 different plates and you just want to do this one simple thing. And in my
Yeah.
experience, when I try to get colleagues or when I try to show people the value of it, people see it and they go, wow, I want to be able to do this. This is so helpful. And then they begin the process and they get
Yeah.
just an onslaught of punches to the face by trying to set.
The terminal
Yeah,
turns people away very, very fast. Once everyone thinks it's great until you open up that black window, and then it's oh
yeah,
no, no, that's not for me. Unfortunately, I think again, this was another thing I was writing today, which was around what ways to get into it and get over that block is to work on something. Now I was writing a promotional email, so I was obviously promoting one of my courses, but it was the gist of it was learn Python by doing something or applying it in a context that you care about. So, I gave the example when I started very originally trying to learn, I wanted to learn Python a couple of different times. I tried a couple of different times and bounced off it at least twice, where I was like, yeah, I'm going to learn this now. This is going to replace MATLAB. This is great. And I started by following tutorials that were nothing to do with engineering, right? So I'm there as a PhD student in engineering, and I'm trying to learn Python by writing classes about cars and the colors of cars and the attributes of cars. And I'm like, this is,
yeah,
I bounced off it basically. But as soon as I started trying to apply the very little knowledge that I did have to things I cared about, which was analysis, structural analysis, generally speaking, I rapidly improved because I could stick with it. I was interested, So context is key, is what I would say as well when it comes to
yeah.
learning how to code.
Totally agree. And for anyone out there that's interested in starting, I think Google Colab is a great way to just take a lot of the setup headaches away, to just allow you to start using Python
Yeah,
simply. And then once you
yeah,
understand that it is possible, then you can start digging into setting up your environment stuff, um, which is a painful process, but also important from a just a work practices perspective.
yeah, yeah, one hundred
Um,
percent.
okay, we're kind of coming up on the closing time, Sean. Can you, just before we get into, I want to ask you about some book recommendations, but before we do, what's your favorite course that you created? Like what do you like them? What topic is your favorite course that you created? What are you most proud of? Because some of those courses are. What's the longest course that you have? Is it like 20 hours plus?
One of them's 18, but the last two or three of that are an appendix, which you don't have to take. So no, I suppose what each one, I was saying this to you earlier, each one is like its own
Yeah,
labor of love, right? So I spend so long on these that by the time I get to the end, each one has its own character in my mind, in a sense. Some of the ones I'm most One of the ones I'm most happy with or proud of, I suppose, because it was bloody hard to do, is the cable
mm,
3D cable net course. That was hard. Like I really went to school on that one. So I really liked that course. Um, slightly easier entry point is the 2D cable course. That's where I started. But another one I really like, because I think it's directly applicable, as we come back to dynamics that we were talking about earlier, is a
yeah,
multi-degree of freedom dynamics course that I put together. That answers a lot of questions for a lot of engineers out there, I think. So that's one of the ones. They'd be two: cable nets and
and you also
dynamics,
have,
probably.
for anyone interested, you also have a bunch of material on YouTube as well that people can check out and get a feel for the type and style and depth of the content
Sure.
as well.
Yeah, there's plenty of stuff on YouTube. That's another thing I need to lean a little bit more into the YouTube channel. And there's some projects there as well, which anyone can take. Just go to the projects tab on the website. They're all free. Just head in and build a little tool. You want to get going in Python, build a little
You know,
calculator, and you can do that with
something
some of
that
those
I thought
projects.
was interesting, just a thought that I had was, you've got this giant library of, engineering focused content, and all these different AI tools are only improving. It'll be interesting over the next couple of years to, train a custom model on all of your material, both from a video perspective and the transcriptions of your lectures, etc.
Mm.
And you'll end up with this, focused engineering education tool. Like, it's interesting to think, what's coming down the pipeline.
Yeah.
Because AI is kind of based on the quality of the data upon which it's trained, right? So you have all of this
Yeah.
like focused engineering content, and it's only going to grow in terms of the amount of content, and it just begs the question of what's coming down the pipeline.
Well, I mean, we part of the new platform, the engineering skills platform. There is an AI, an inbuilt AI assistant on there, and all of the infrastructure behind the scenes is there to fine tune that to the content that I already have. It's just a mammoth task to feed it all of the content. So I've started feeding in some of the content, some of the video transcripts and things. That's a longer term project. But I agree with you. It is interesting to see where it's all going. One just hopes that there's a place for the real
There always is.
human
There always
teacher
is.
like me in the future.
Somebody has
I hope
to
so.
hold a remote control. Somebody has to be in charge of the robots, I guess, at least for now. I've had some success with sort of custom tools, training them on like stuff like the documentation for SAP 2000 API, things like that. So there's lots of good opportunity out there to use AI tools and train them on specific documents. So book recommendations. Is there any books that leap out to you, and don't necessarily have to be anything to do with engineering, just books that you liked?
There's one book that I give away to more people than any other book and send it to people as the 4-Hour
Tim
Work
Ferriss,
Week.
yeah.
Actually,
Oh, yeah.
do you know that one? Yeah. I work a lot more than 4 hours a week. I sort of hasten to add, but the 4-Hour Work Week for me was a very good book because it's really more about how do you design a lifestyle that you want. That really spoke to me at the time, and it has had quite an impact on my life anyway, in terms of the decisions I make and we make, me and my wife here. So that's a great book, well worth it.
I agree.
Worth a read,
I
I
love
think.
that book. I'd love to see an updated version, because that book came out when I was just finished university, or around the same time. I'd love to see an updated version, because we do live in a different world. But I remember, like, that book had a big impact on me too. And I remember I was getting these mushroom supplements from, I can't remember, some online health food store that were like help you focus and stuff, and they were expensive. So I saw from something from the 4-Hour Work Week, I emailed one of the manufacturing facilities in China that did bulk, that produced
All right,
it in
okay, you
bulk.
went for it then, yeah.
and I asked them for a sample of, like, I can't remember what it was, like 500 grams, which was a huge amount, which would have cost hundreds of dollars at the time. And they were like, "This guy is a serious distributor. Let's get him the sample, and we'll take it." That whatever they sent me lasted me for about 4 years. so that's
Yeah, you really took Tim Ferriss's message. I mean, I just went teaching online, but you really went for it with
yeah. Well,
supplements.
it was
So
just
no,
for
I
me.
like
I
it. Very
wasn't
good.
selling them. I was just No, it was just
You
they're
weren't
in my
selling.
desk
You weren't
here at my
selling. Yeah.
office, and I was sprinkling it into my coffee. But so
Very
I'm
good.
a big fan of that book. Highly recommend it. People could probably find better things to do
Yeah.
out of that book than what I did.
Yeah.
Um,
Probably. Yeah.
so before we finish up, is there anything else that you want to mention, or anything else that's in the pipeline for you that you want to talk about?
Lots of things in the pipeline. One thing you might be interested in, considering you're interested in Blender, I've started working on a Blender a plugin, a structural analysis plugin for Blender. So
Interesting.
that's going to be. I'm deep in that now at the minute. I'm loving it. The process of building and designing it.
So
So it's early
what's the
days, but
vision for this?
that
What is it?
Oh, the vision changes
Yeah.
every day. But I mean, initially, so a lot of what I do in, some of the courses is we'll model a structure in Blender and then we'll export the
Yep.
geometry for that and analyze it. But that's just a process of running custom scripts at the minute. And so this idea started off with, like, let's just make a plugin that we can just do this from the interface. We don't need, we can set restraints, we can set loads. We don't have to go into running custom codes. It's all just in the interface. That's where it started. And then, like all ideas I end up getting, it gets legs, and it's sort of, well, what if we did the analysis too, and then what if we sort of visualize the results all inside Blender, and you very quickly start. It very quickly grows as an idea. It's still very early, but that's something that I'm excited to share with the crowd, with the audience for engineering skills, because there's a real movement now in terms of using Blender within the construction, or trying to make use of it within a sort of engineering and construction industry. So yeah, that's just an idea I'm playing around with at the minute. It's probably going to be a course as well as a plugin that I'll
That's a
offer as
very
well.
cool idea. And just to give you some context, the way that I use Blender is, I think it's a fantastic modeling tool, very intuitive, like the different shortcuts and how quickly that you can build geometric shapes. Especially for me, I'll often have, hydraulic structures with curved walls or bell mouth intakes and things that are just tedious and difficult to do in traditional finite element software like commercial packages. So
Yeah.
I'll build my structures in Blender and I'll get the shapes and the geometry how I want them, and then I import those into my whatever it is, ANSYS or SAP 2000 or whatever, to actually run my analysis. But if people haven't used Blender, once you get over that initial learning curve of just understanding where everything is and how it works, the flow of building stuff is very, very fast and very, very smooth. Much more so than the node-based shenanigans in SAP 2000.
Yeah, absolutely. And again, it's just another advertisement for Python. Blender has a full Python API. So if you know Python, you can basically interact with Blender programmatically, which, if you think it's a useful tool just using the interface, when you start using its API, it just opens doors. It really does. So huge fan of Blender. Been a long time Blender head since 2009 probably. So yeah, I'm really excited actually to see what can we do in sort of structural analysis realm with Blender. So it's kind of watch this space. No big announcements or anything.
Very cool. I'm excited to hear about that. Okay, Seán, thank you very much for your time. It's been a blast. Maybe we'll do one again in the future on some dynamics. Yeah. Okay. Let's stay on the line here and we'll straighten it out.